Okay, this is our 12.1 Edpuzzle on the first 13 slides of astronomy. We're going to start astronomy by talking about the Big Bang Theory. So the Big Bang Theory, it states that our universe all started with one small point. And that had all the matter and all the energy that we have now today was encapsulated in this one small point. A huge explosion occurred, and all of that matter and energy then proceeded to go outward in all directions, and it had extreme heat and pressure from this explosion, and it happened in 1 second. That universe expanded from that one single point. And the interesting thing is that our universe is still expanding and cooling today. Galaxies is how our universe is divided up, and those galaxies consist of star, dust, and gas. There are many types of galaxies, and there are about 100 billion galaxies that are estimated to actually exist. And in the Milky Way alone, which is our galaxy, has over 100 billion stars. And when we're talking about galaxies, we have to also mention the black holes. These black holes are located in the center of galaxies, and the galaxies are revolving and rotating around this black hole. And then you can see there on the left-hand side is a picture that they captured of a black hole. So the spiral galaxy is one of those types, and that is the type of galaxy that our Milky Way is. They are described to be flat, rotating disks, again, containing those stars, dust, and gas. And there is a central concentration of those stars, which creates more of a bulge in that type of galaxy. On the picture to the left here, you can see where we are at in this big galaxy. Kind of on that left bottom corner. And Miss Laporte there is pointing to the sun, which is a part of our galaxy. The Hubble Space Telescope, I'm sure, is something that you are familiar with. It housed on a telescope in orbit around the Earth. It was launched back in 1990, and it was actually only said to be up there for a few years, and it has definitely exceeded the expectations of its life up there. It is going to be replaced with another telescope called the James Webb Space Telescope. Or this coming up year, actually, sorry, it's going to be launched this year coming up on Halloween. Our Hubble Space Telescope has discovered many discovered galaxies and dark energy, and has helped to determine the age of our universe, which is about 13.8 billion years old. These are some of the images that Hubble has captured. We've got the Pillars of Creation down there on the left side, in the Eagle Nebula, which is said to be about 6,500 to about 7,000 light years from Earth. The Butterfly Nebula is on the top right there, in the constellation of Scorpius, which is about 4,000 light years from Earth. And the bottom there, which are the interacting spiral galaxies in constellation Canis Major, which is 130 million light years away. To kind of give you an idea of what that means by light years, in case you're not sure how that works, what is that time frame? It would be how many years it would take traveling at the speed of light to get to that particular place.
All right, so some of the other astronomical tools that we've used besides telescopes like Hubble and like we'll use the James Webb are space probes. And basically, a probe is an unmanned spacecraft carrying various types of scientific instruments that is sent out, launched from Earth, and sent out into space, and is able to send data and information back to our planet. So the first probe that NASA launched was in 1958, and that was Explorer 1. That's this guy over here. Voyager 1, another famous space probe in 1977, that's this guy right here, was sent out and has reached what's called interstellar space now. And that means it's no longer in our solar system, it's interstellar. Inter meaning between, stellar meaning stars. So it's actually in between the sun and other stars. And it reached that location in 2012. And then the images on the bottom are pictures from the various Mars rovers from 2000, the late 90s, early 2000s, and into this century. And you can see here Sojourner, Spirit and Opportunity, and then Curiosity. Those are the previous Mars rovers. And you can see some of their images, the tire tracks on Mars, some of the images of various parts of Mars's land. And then obviously this year, which we've talked about before, Mars 2020's Perseverance rover. And there it is down there on the bottom, taking a cool little selfie with its buddy Ingenuity, the helicopter that's been doing its first couple of flights. Perseverance was launched on July 30th of 2020 and landed on Mars on February 18th, 2021. And you can see there the different mission goals. Obviously, the key mission being to find signs of ancient microbial life on Mars. That's the goal. And this probe is capable of collecting data samples that it's actually going to return to Earth. It's going to do some tests. It obviously has video and flight capabilities as well. And it's going to do a lot of other resource checks for the planet Mars. So you can see Ingenuity there getting ready to take its flight. You can see some images of Mars. And this picture on the top left was its first picture when it landed on February 18th, which is pretty cool. All right, so as we head into space and we take a look, besides the big picture stuff like galaxies and black holes, etc., the universe is made up of lots of these things called stars. All right, you look in the night sky and you can see several of them, but that's only a fraction of the total stars in our universe. And stars are basically big, huge, dense spheres of gas and plasma, which plasma, remember, is superheated gas. And basically just those conditions, that amount of mass, that amount of hydrogen gas is going to result in the perfect situation for fusion, all right, one of those nuclear processes that we talked about back in November. And this process happens very, very deep in what's called the core of that star. And fusion, the process, generates an enormous amount of heat. And depending on the amount of mass, those stars can last, can perform fusion for billions of years, all right? There are a couple of different ways in which we organize and categorize stars. The first is by size. So from large to small, we have some various names. A supergiant is the largest, followed by a giant, a medium-sized star, which is what our sun would be considered, white dwarf, which is very, very tiny. And then even tinier than that is something called a neutron star. And we'll talk about some more of those in a minute. And the other way we categorize these stars are by temperature. And so from hot to cold, these stars are going to appear different colors. So the hottest stars are actually going to appear blue, which is very interesting. But if you think about like a flame, the hottest part's going to be in the center, and that tends to be blue. So blue is our hottest. Then we get cooler with white, yellow. So yellow-orange is about where our sun is at. So it's kind of a, not that hot, but not that cold. Again, kind of a medium star. And then red being the coolest. And again, the smaller the size of the star, the hotter they tend to be, which is, again, kind of an interesting, maybe counterintuitive point there. So very briefly, in terms of how we end up with stars, how they are formed, etc., stars are born in something called a nebula. In this case, pointed out a picture that Hubble had taken earlier of the Eagle Nebula. And so basically it's just a huge cloud of gases. And that's where stars are born. As these gases, these particles start to coalesce, they start to come together, you end up with things called protostars. And so as these hydrogen molecules and helium molecules start to clump together, and as they get closer, the large amount of mass and pressure is going to start to allow for fusion to take place. And that gets literally the ball rolling. And so large amounts of energy as a result of that fusion process starts to get released, and you start seeing a shine in those stars. You can see pictured here the life cycle of a star takes a couple of different pathways depending on the star's mass. And eventually, over time, as that star goes through, it burns through its hydrogen, it does all that fusion, eventually it's going to run out of fuel. It's going to run out of hydrogen. And so what happens then are two different options, all right? Regardless, the star is going to kind of swell up, kind of like a balloon, you know, kind of enlarging, getting to be those red giants or supergiants, depending on the original mass. And then one of two things is going to happen in terms of that star's death. And that, again, depends on what that star's original mass was. So our star, the sun, is a medium-sized star. And so what's going to happen to it, once it swells up, it's going to expand out when it starts to die. It's going to destroy Mercury and Venus and potentially even our planet. That's going to swell out. And then we're going to end up with a teeny tiny star called a white dwarf. So that big swollen balloon's going to kind of shrivel back down into this very dense, very hot remnant of our sun. And so you can see that not only will you have this dense center, but you're going to have these kind of cool outer layers of gases and of various elements. And that's called a planetary nebula. So you can see here, the white dwarf is actually right in the center of that. And all of this gas around kind of looks like a cat's eye, is what's called a planetary nebula. But there's not enough matter here. There's not enough gases here for new stars to coalesce like we saw earlier on. So eventually those white dwarfs are going to burn out, and then they'll become what's called a black dwarf, where they won't shine anymore. Lastly, if you are more massive than our sun, so if you have a mass that's maybe 2 to 5 to 7 times more massive than our sun, you're going to go out literally with a bang. So as that star swells and swells and swells and swells into that red supergiant, it's eventually going to undergo what's called a supernova. So it's going to explode. And that's because its gravity essentially is going to collapse in on itself. Supernovas are only last for a very short time. We've recorded a few of them on some of our scientific instruments. And eventually that supernova area is going to cool. It'll cool into a nebula, so you can see a couple of those right here. Again, this is where new stars are going to be born. So the death of a really big old star is going to provide the material for baby new stars. And then you can end up with one of two possibilities. One, you could have the remnant of that large star become a neutron star, which is even tinier than white dwarf, even more dense, even more hot. But it's so tiny that it doesn't really produce a lot of light. Okay. Sometimes those neutron stars can get a little crazy, and they can be pulsars and and quasars and all sorts of other cool things that we can talk about later. But that's one option. The other is, if the star was so massive when that supernova happened, that gravity might have been too much for those remnants to handle, that it might have collapsed in on itself. And that has resulted in what's called a black hole. And black holes are very mysterious, and we know little to nothing about them. But they have what's called a singularity in the center. So very similar to what Ms. Case started talking about in the beginning. And that is a point where the gravity is so immense, so strong, that light can't even come out of it. So everything gets sucked into it. And that's why a black hole essentially is this kind of absence of light space located at the center of every galaxy, but also in other locations. And they provide lots of good potential for science fiction, as well as for us scientists trying to figure out the mysteries of the universe.